Okay, so when we solved quadratic function, when we completed the square for quadratic functions, that's where we were taking something like y equals ax squared plus bx plus c and showing it in the form ax minus b squared plus c. And we did this so we could find the vertex, right? If we have an equation in either of these two forms, an equation means 0 equals, right? Or once it's simplified, right? So only one variable, or 0 equals this. Those are the equations. This is functions. Okay, then we practiced yesterday. You could solve this by factoring. But what if you can't factor it? Okay, then what do? Well, if you could put it into this form, then you can solve this. And we've done some like this before. When it's in this form, we bring the q over, divide by a, take the square root of both sides, okay, and then solve for x. So that's what we're basically looking at today, is to solve an equation like this by completing the square. And really from this form, getting to x is called the square root principle. We don't want to do all this work on this side and then solve it. We kind of want to do it at the same time, solve and complete the square at the same time. If we know right away that we're solving the equation. So that's what we're learning today. And then tomorrow is the other way of solving this, if we can't factor it, is the quadratic formula. We'll probably maybe start today, but that's going to be sort of the most common method other than factoring. Okay, so you check if you can factor it. If you can't, usually you'll go to the quadratic formula rather than doing too many with completing the square. In any case, to start today, practice from yesterday, solve by factoring. So biggest thing is to get one side equal to 0. Okay, so expand out any brackets, and remember with this one, do not divide by m. Okay, give everything on one side, no dividing, because you'll lose the solution. So I'll give you a couple minutes to work on those. Okay, so there are the solutions to those three. Biggest thing, in the first one, you could factor out a 2 to make it smaller numbers. I would just divide because it's an equation now. Whatever you do to one side, you can do to the other. So I just divide by 2, and then it's easier to factor. Next one, biggest thing is do not divide by m. Get one side equal to 0. Just like all the other quadratics. This one, you got to get rid of all the brackets. Collect like terms to get one side equal to 0. It factors to a binomial squared, so there's just one solution, and n equals 1/2. When we start talking about what's called the discriminant, as part of the quadratic formula sort of lesson, we might describe this as having 2 equal real roots because of the multiplicity of 2 here, but it's really one distinct solution, right? It's just 1/2, nothing else. Okay, so solve using the square root principle. So again, we haven't got to the completed square method. These all have their squares have been completed. You've done all the work like this was y equals, or y equals, or y equals. It's already close to being in vertex form, except for this one, because there's a 3 in front, but it still can be solved by what's called the square root principle. That means you're going to take the square root, right? So you want to get the x squared term by itself. So here, actually, you might want to divide by 3 to start, if you see that it's common. So this is going to be x squared minus 25 equals 0. And so by the square root principle, we're not going to factor it. We're going to bring the 25 over to the right and then take the square root of 25, which we have to do. You have to take the positive and the negative root. And so that's going to be plus or minus 5. Okay? Solving by factoring from here, we would have had x plus 5 times x minus 5, which gives you the same solutions, right? It's just another method. Square root principle means you're isolating the x squared term. Okay? So here, the term with x in it is here, this whole thing. So you might not see that you can divide 2 out. So maybe what you'll do is, if you do see that you can divide 2, then do it. But in this case, maybe you won't. So bring the 6 over. So square root principle is a little bit different from factoring and when we learn the quadratic formula. We actually don't want one side to be 0, but it has to be completed squared there. So this would equal 6, then divide by 2. You're more likely to see it there. Okay? But you can do it at the beginning if you see it. Those divide out. So then you get x minus 1 squared equals 3. Right? So x is, you're getting down, you're working your way back down to just x. So the opposite of squaring a number is square rooting. I'll do it in red actually. And you need a plus or minus because positive squared is the same as a negative square. Okay? And so that gives you x minus 1 equals plus or minus root 3. And then to get x by itself, you add 1 to both sides. You cannot collect like terms, right? A radical, square root, cannot be added with an integer. So usually we show the integer part first, and then the radical part second. Okay? That's 2 solutions. If you were to write them out, you'd have 1 plus root 3 and 1 minus root 3. Okay? So you can either show it there or you can use the plus or minus. When we use the quadratic formula, we're going to use the plus or minus a lot. So if we ask you on a test to solve by the square root principle, probably we'll just have 1 like that. That's the steps. Okay? You don't then go and say, oh, I'm going to use quadratic formula, even though they ask for square root principle. Or I'm going to go factor, even though they ask for square root principle. In this case, you can solve by factoring anyway. You end up with a solution that has a irrational number in it, then you can't solve by factoring. Factoring is for integers, right, and fractions. So basically a rational number, it's not irrational. And then this one here, it's not in the vertex form of a completed square, but it certainly has the x in brackets squared. So we're going to bring the 12 over. Okay, then square root both sides. Plus or minus. And you always want to simplify a radical. So here, root 12, that simplifies to 2 root 3. Okay, don't leave it unsimplified. Then we're going to bring the 5 over by adding. So it's going to be 3x equals 5 plus or minus 2 root 3. And then we divide by 3. And you just, you can leave it just like that, okay? Or if you want to set it up into separate, it would be plus 2 root 3 over 3, and 5 minus 2 root 3 over 3. Okay? That dividing is underneath everything there. So don't be lazy with it. Okay, so that's the square root principle where the x was already in brackets squared, only one term with x in it. Now, for completing the square, to solve by completing the square, you look at this and you have to think about, okay, if this was a function, how would I start to put it into vertex form? So normally you would factor out anything in front of x squared. There's nothing to factor out. And I would leave a space and put them, I subtract 32. Okay? In this case, we have an equal 0. So when we did the square root principle, the first thing we often did was bring that constant term, whatever it was. This might not be the constant term in the vertex form, but it's certainly constant. So what the first thing to do here is bring the constant to the right. Then it's separated anyway. I wouldn't even need the brackets that I have on the left. Okay, so all I've done is move the 32 by adding it to both sides. And put 2 brackets in, which doesn't change anything. So then, if you remember back to functions, we would take half of negative 4 and square it. So negative 2 squared is positive 4. So we would add it there. Normally, we would also subtract it. But let's think. Okay, so this is quite a simple one. So when we get to ones that might have a coefficient here, you are going to divide by that coefficient, just like you would normally factor out. So no matter what, if we add here to balance our equation, we're going to add on the other side, rather than adding and subtracting. Because we want to solve, our goal is to actually solve this. So why keep everything on one side and then do more steps to get it undone? Okay, so we're trying to solve it at the same time as completing the square. Then here we can factor this. Right, that's going to factor to x minus 2 squared. Collect like terms on the right. And now we can solve that, right? We're going to take the square root. Okay. And then add 2. And collect like terms. Those are actually integers, right? So x is negative 4 and 8. So this one, if we had factored it, I mean, we could solve by factoring, right? Two numbers that multiply to negative 32 add to negative 4. So you can kind of check it both ways, but you were asked to solve by completing the square, so that's what we did. To balance our equations, we added 4 to the left side. So if you add something, you either got to subtract it on the same side or add it to the other side. Okay, indeed, that you couldn't even solve by factoring, right? So what we're going to do here, keep the x terms on the left. Bring the 4 over. Okay. So you really don't need to have brackets around that, but you can. Then I take half of 12 and square it. So 6 squared is 36. I add it to both sides. Okay, rather than subtracting it on one side and then moving it over later. Might as well add it now. Then that's a perfect square trinomial. That's the whole point of this. This factors to x plus 6 squared. Collect like terms on the right. Take the square root. Simplify the radical. And that simplifies to 2 root 10. And you can't do anything more, right? Can't add an integer with an irrational. Okay, so turn over the page. Now we have some coefficients in front, okay? Again, I'm going to bring the 13 over to start. Okay, then want to get rid of that 2, okay? So yeah, you could factor it, but then you have to do that adding and subtracting on the same side. It's an equation. I would divide everything by 2. As long as you do the same to one side as the other, then you're good. Unfortunately, as fractions, but that's just the way it is. Use fractions unless it's an application question. Okay, then you can use decimals. Okay, so fractions. Then you're going to do questions. Yeah, but then when you add that number, you're going to have to multiply it by 2 to know what it's going to be on the other side. So you just have to be aware of that. Okay, so then we're going to take half. So half of negative 9 over 2 and square that. So that's not negative 9 over 4 squared. That's going to be plus 81 over 4 squared is 16. So if you've chosen that number correctly, then it's going to be the square root of that with the same sign, okay, or half of 9 over 2, which is 9 over 4. And then you need a common denominator here. So 2 times 8 is 16. 13 times 8 is what? 104. Okay, then you can simplify this in the same step. Okay, so that's 185. And then simplify. Or sorry, get the x by itself, but also simplify the radical. Right, so this is going to be x equals 9 over 4 plus or minus 185. 5 goes into that 3 times with 3, 37. So you can't simplify root 185, but root of 16 is 4. And so you can leave it like that. You can show it because they have a common denominator, or even if they didn't, you might find a common denominator. So more often than not, that's how we show it, as one graph, especially when we get to the quadratic formula. So if you wanted to keep everything on one side, then you would and factor, you'd have a 2 out front, you would add and subtract this, then you multiply that by 2, and then bring it over. This would be 2 here, this would be 13. Bring it to the left and go from there. This is just maybe one step faster. So next one, it's got a 3 in front. So again, I'm going to bring the 4 over to the right. Oh, it's minus 4 when it's on the right. And divide both sides by 3. Okay, then take half of negative 8 and square it. So that's 4 squared is 16. Okay, you're always adding on the left. And then if you're doing the same on the right, it's adding as well. Then factoring that, that's going to be x minus 4. Common denominator here with 3, we have multiply 16 times 3, which is 48. So really that's 44 over 3. And square root. Notice how in this one, can't simplify, you can simplify the numerator a little bit, can't simplify the denominator. Root 3 is root 3. So what you want to do is rationalize the denominator. So this is going to be x equals 4 plus or minus, and I would rationalize this. So top root 3, top and bottom. And so that's going to be 4 plus or minus 2 root 33 over 3. And you could find a common denominator if you want. Yeah, if you want to get a common denominator, then that would be 12 plus or minus 2 root 33 all over 3. Okay. That's more of what it would look like if you use quadratic formula. which we'll talk about. Right, and then I think there's just a couple of application questions where we're asking you to use this method. Really on application questions on a test, you'll get to use whatever algebraic method you want. Graphically, if we tell you, you can use graphically. So a defender kicks a soccer ball away from her own goal line. The path of the kicked soccer ball can be approximated by that quadratic function, where x is the horizontal distance from the goal line. So if you're looking at the side of the field here, here's the goal. So it's kicked out from the goal, or the goal line, I guess. So, I don't know soccer rules very well. I'm assuming that's the goal line. Anyway, this is your x distance here. So really, actually, if we were graphing this, it would be the other way around. So I put the goal line here, and then it would be kicked out like this. This would be your height, and this is your x. Okay? So it says, determine how far the soccer ball is from the goal line when it's kicked. So the goal line actually then, so basically it's probably, because as I said, I don't know soccer very well, but the goal line is probably here. Who plays soccer? Is there like a square out from the goal line, from the actual goal? A box, 18 yards? Yeah. Okay. Okay. So probably, yeah, so here, because she's kicking it away from her goal. So in any case here, we want to know what x is when the height is 0. Okay, there'll be two values. One will be bigger than the other, right? So here we want to know x equals what when the height equals 0. So 0 equals negative 0.06x squared, 3.168x minus 35.34. So it does give a lot of decimals. So we can use decimals in our work. Doesn't say what method to use, but we are learning about completing the square today, so let's use that method. Okay, so what I would, first of all, think about, if I divide everything by negative 0.06, does it go into everything? If it does, that's awesome. If not, I would probably multiply through to get rid of the decimals by a power of 10. But get out your calculator and just see. Because we don't want to do any rounding in our question. But let's see if I go 3.168 divided by negative, not that the negative really matters right now, but okay, so that goes to a nicer number, right? Still one decimal place, but no repeating decimals, anything like that. 35.34 divided by negative 0.06, and that gets rid of all the decimals. So that's what I'm going to do as part of my steps here. So first of all, I've got everything on one side, 0 on the other. I'm going to bring this over, or you could divide by negative 0.06. Maybe we'll do that to start here, since we just did all that work, so that you can do it now rather than later. Okay. Anything, 0 divided by anything is 0. That's obviously going to give me x squared. I already did that dividing in my calculator, and it was negative 52.8. So subtract 52.8x, and then a negative divided by a negative would be a positive 589. So then I bring this over here. How did I change it? So that's going to be negative 589 equals x squared minus 52.8x. Now, if you want to switch the whole thing, you can. Then we want to take half of negative 52.8 and square that. So, you don't really need the negative in there. A negative squared is a positive, as a positive squared is. So you can just go 52.8 divided by 2 and then square it. So 696.96. 696.96, both sides. Okay, it's already in your calculator. You can subtract your 589, the 107.96. And this would factor to x minus 26.4 squared. Okay, because it's an application, we're going to want to get a decimal nearest 10, but we're doing it algebraically, right? So then we're going to take the square root here. And I'm going to put the x on the left now. So x minus 26.4 equals plus or minus the root of 107.96. Okay, I'm going to keep it like that because if it gives me a lot of decimal places, I don't want to be copying them down. Yeah, so I don't want to write all that out. That's exact right now, but now I use my calculator to get the actual two values. So 26.4 plus the root of 107.96. And 26.4 minus the root of 107.96. I'll show you another thing. So 16.01 basically. Here's 10. Okay. So just before we analyze those answers, if you have a newer version of the calculator and you've done the one with the plus, if you go up and so if you have the ability to arrow up, so that's selected, enter on it, so it copies it out. Then you could go back and just change that to a minus and enter on it. Okay, so just be aware that you can do that. Okay, and so then in our answer here, so the goal line that you're going to be, if she's kicking away from her own goal line, then, so it's a defenseman, right? So the defender is out here. Here's your goal line. This is our 16, and this is the bigger one, right? So she would be, so therefore your statement answer, the defender is kicking away at 16.0 meters from the goal line. So I think they're assuming the goal line's right at the goal, right? The other are, I don't know what do they call it, the key? No, what do they call it? Okay, 18 o'clock, yeah. then you can tell here that the ball lands at 36.8 meters from the goal line. So we don't have to do any work here. So therefore, oh, actually, I shouldn't say that. How far does the soccer ball travel before it hits the ground? So remember, here's your diagram. This is 16.0. This is 36.8. That difference is what we want. So distance traveled, kind of like on the last test, right? Now, we want to use unrounded, or at least 3 decimal places. I think that was, we'll put that. We have our calculator, which is great, so you don't have to, just don't clear your calculator, right? Like, keep going, so in case you need the numbers. So here, I would go back up to that, if you have the capability, or at least copy out 3 decimal places from there. And then minus the last answer, or select it, and then it would be 20, so 1 decimal place now would be 20.8.